Hello friends, this is Prasant Raj Kuswaha here to give some useful information about hydrology. Let's begin on the topic hydrology. Hydrology. Hydrology engineering may be defined as the multidisciplinary specialization of civil engineering that deals with the occurrence, circulation, and distribution of water on the earth. Hydrology and civil engineering may be understood as the branch of engineering that deals with the study of water resources. It is also commonly referred as water resources engineering. Hydrology engineering is focused on the scientific study of the water cycle and water resources and water resource sustainability. It mainly focuses on the planning, design, analysis, and operation of water-related projects and construction by the utilization and efficient management of the water resources. Now let us look towards the history of the engineering hydrology. Engineering hydrology has been an important study for a very long time. Ever since the dawn of civilization, various hydraulic structures have been constructed by the use of hydrological tools. Irrigation activities were evident since the history of Chinese development. The development and advancement of engineering hydrology began in the 1st century BS. Robert Elmer Horton is the father of modern engineering and hydrology. He was an American civil engineer and soil scientist. Now, let us look towards the importance of hydrology, why we require hydrology, why we need hydrology. So, let us have a look. It is necessary to determine the maximum probable flood at proposed construction site. For example, dam construction, wherever we construct dams, reservoirs, we have to determine the maximum probable flood level so that it should not overcome the construction. In order to determine the hydrology, the knowledge of hydrology is very important. So it facilitates engineers and hydrologists for establishing the relation between the surface water of catchment and underground water resources. It also enables to determine the flow over various hydraulic structures such as spillway, highway culverts, urban storm drainage systems, etc. It is important for studying the on-site drainage and seepage condition before the commencement of any engineering construction. The nature of variation of water flow or rainfall pattern etc. can be obtained from the use of engineering hydrology applications. It is necessary for determining the reservoir capacity to assure an adequate supply of water for domestic and other purposes. Now, let's look towards the application area where we use hydrology. Being a civil engineer, irrigation projects and scheme for irrigation projects and that schemes we have to determine the rainfall, flood level, how much is the rainfall. So here we utilize our hydrological information, hydrological knowledge. Hydroelectric power generation project and dam construction. As I said, for dam also we require the possibilities of flood levels. So here also it is required. Water supply project to supply waters, the knowledge of hydrology is very important. So we utilize our hydrological knowledge here also. Disaster prevention or flood control projects. Now let us look towards the scope of hydrology in civil engineering. The first one, the determination of maximum probable flood. The maximum probable flood at a proposed site can be determined by techniques of engineering hydrology. It is necessary to determine the frequency and occurrence of floods for designing and building hydraulic structures such as dam, flood control structures, and reservoirs. Now the second one, determination of maximum intensity of storm. The determination of maximum intensity of storm is necessary to determine the drainage condition at the site and to design the needed drainage system. So third one, determination of water yield of basin. For the design and construction of various structures such as municipal water tank, reservoirs, inland navigation, it is necessary to determine the yield of the basin, that is the occurrence, frequency and the quantity of water that can be obtained from the basin. The last one, groundwater development study. Engineering hydrology facilitates the study of groundwater and its development. So these are some of the scopes of hydrology in civil engineering. Now let us know about the hydrological cycle. What actually hydrological cycle is? The hydrological cycle is commonly referred as the water cycle. In our common language, we use it as water cycle. The hydrological cycle may be defined as the process in which water from all freshwater sources, oceans, and land move to the atmosphere and back in the form of precipitation. It is inevitable for the balance in the ecosystem and biological system of the earth. It is inevitably necessary for the cycling and processing of solar energy, sediments, and other elements that are necessary for sustaining life on Earth. The hydrological cycle consists of series of processes such as evaporation, precipitation, percolation, runoff, etc. It is a continuous cycle. Now let us look towards the components of hydrological cycle. What are the components in this hydrological cycle? The first and foremost is the precipitation. Precipitation is the form of water that falls from the atmosphere to the surface of the earth, such as rain, diesel, snow, dew, etc. Now the second one is evaporation. It is the physical process in which the water from the land and water on the surface of the earth is converted to the vapor form and gets evaporated to the atmosphere. The third one is the transpiration. Transpiration is the process in which water from the soil is absorbed by the plants, that is the roots of the plants, and discharged back to the atmosphere through the leaves, that is the little pores present on the leaves that are called stomata, through which they transpirate or exhale the water in the form of vapors, and this process is known as transpiration. Now evapotranspiration. Evapotranspiration is the combined process of evaporation and transpiration, which involves that which involves the transfer of water to the atmosphere both from the water source and vegetation. Infiltration. Infiltration is the movement of water from the ground surface to the underlying soil layer. Percolation. It is the movement of subsurface water to the water table. Overland flow. Overland flow is the runoff that flows through the surface of the ground to the stream or the river. Surface runoff. It is the overland flow as well as the precipitation that flows to the stream or river. That is after the precipitation, after rain, the water flows without percolating as are the surface runoff. Let us look towards the major aspects of hydrology in civil engineering. analysis and estimation of water resources of the earth, both overground and underground. Study and analysis of hydrological cycle, its components, and the interaction among the components. The study, analysis, forecast, and mitigation of water-related disasters such as floods, drought, etc. Now let us look towards the hydrological cycle. This is the hydrological cycle. This is how it takes place. So as we all can see, this is surface water. From the surface water, the water is converted in the form of vapor, which rises in the atmosphere. Even the transpiration takes place through these plants, and the water present in the soils are absorbed by the plants and again evaporated to the atmosphere. Those evaporated vapors forms clouds in the atmosphere, and those clouds when gets condensed, after the condensation it again falls back to the ground in the form of precipitation, that is the rainfall, snow, dew, etc. When it falls to the ground, the surface runoff takes place. The surface runoff is the without any percolation of the water that falls on the land are transferred back to the river, stream, or reservoir is the surface runoff, while some portion of the water gets infiltrated or percolated back to the surface of the soils. When these infiltrated or percolated waters, they form underground waters, and the surface water, the surface runoff water, they go to the river, they joins river, and again back moves back towards the ocean, where again evaporation takes place. The underground waters are absorbed by the plants, and after absorbing, again they are thrown back towards through the process called transpiration, and this cycles continuously takes place. It is a never ending process. The from one side it is getting evaporated, and other side the same evaporated vapor is getting condensed and falling back in the form of water, river, rain, and finally reaching the river there again. So it is moving towards the oceans. So it is a continuous process, never ending process. So this is the hydrological cycle, which we also call as water cycle. Thank you.